In this section, I'm going to briefly discuss the exceptions to the octet rule, which you can find in the Lewis structures, and also I'm going to show you the NASB method for figuring out what the Lewis structures are for these. Most of the common elements that we see are going to follow the octet rule. Obviously, hydrogen is an exception because it only needs 2 electrons. Elements in group 3A, okay, also do not have enough valence electrons to form an octet. And so one of the primary examples of that is boron, which is B. Boron only requires 6 electrons to be happy, and rather than the full octet. And this has to do with some energy considerations of the orbitals. So it is an exception, and so it will not have a full octet. So boron is the example of less than an octet exception to the octet rule. Elements in the third row have an empty d orbital, and so it can accept some electrons in certain circumstances. And so elements like phosphorus and sulfur can have more than an octet. Now they don't have to, but they can. And so what we'll see when we look at the NASB method, which helps us kind of figure this out, is that you can always put greater than an octet on the central atom if you have electrons left over. And so I'm going to show you how to do this NASB method that I've been talking about. So using the NASB method, and this is just another method where you kind of use a little bit of math to figure these out, and it's not so much relying on you inferring things and all that. So the first thing you do is you write the correct skeletal structure for the molecule like we did before and connect those with bonds. So you go ahead and connect each one of that individual skeleton with a bond. The least electronegative atom is always going to be the central atom. And so electronegativity we haven't talked about so much, but it's a high and right periodic trend. And so what that means is that the farther to the right or higher it is on the periodic table, the more electronegative it is. Okay? So carbon is almost always a central atom when it is in a particular compound or molecule, and oxygen, things like that. So they're very electronegative. Those are our nonmetals over there that we see. So the farther over they are, or the higher they are, then the more likely they are to be that central atom. The least electronegative ones are going to be the more electronegatives, sorry, are going to be the terminals, or the ones that are attached around that. And hydrogen's always going to be on the outside because it can only form one bond. You determine the number of needed valence electrons. So if it's not hydrogen, it needs 8. And so you basically look at how many non-hydrogen atoms you have and multiply that by 8. And that gives you how many are needed. And if you have any hydrogens, you're going to need 2 electrons for each one of those. Okay? That's the N of the NASB, needed. Then the available is how many valence electrons each one of those atoms is bringing in. Okay, so like hydrogen has 1 valence electron, so that's how many it brings. Boron had 3 because it was in the third one. Bromine, Br, has 7 because it's in 7A. So remember, the valence are the group numbers. That's how you can tell how many, okay? S is for shared. Okay, or you can think of it as subtract, because once you've got the needed and the available, all you do is subtract those 2 numbers, and that tells you how many electrons you're going to have to share. Then you distribute those electrons around the outer atoms to give the octets or a duet for the hydrogen. And then whatever you have left over, you're going to finish that octet, right? And then if you have any left over, then they're going to go on the central atom. Now, all of the electrons have to be accounted for, and so I'm going to show you how to do that. It may look a little dicey at first, but it's really, really not, okay? Now, if they if anything on there doesn't have an octet, you remember you can form a double or a triple bond. What I like about this method though is if it's and I just kind of came up with this pecan, you know, not like the nut, but say pecan, okay? So P, C, O, N, or S, those atoms can all form double bonds. If it's not one of those, you can't double bond, okay? Can't double bond. So if you have a fluorine, for example, the F, it is not a pecan, P-C-O-N-S, so it can't form double bonds. To form triple bonds, it has to be C-O-N-S, a con. Okay, so carbon, oxygen, nitrogen, or sulfur. So double bonds, phosphorus, carbon, oxygen, nitrogen, sulfur. Triple bonds, carbon, oxygen, nitrogen, sulfur. If any electrons are left over, you can place them on that central atom after you've done all the double bonding or whatever that is allowed, because you can violate the octet rule with the central atom. Okay, so let me kind of show you. So this is just so that you'll have like one slide with the whole thing on it. So basically this is what I said. N is needed. So that's 8 times the non-hydrogen atoms you have plus 2 times the hydrogens. Then the A is how many are available. That's the sum of all the valence electrons you're bringing in. S is needed minus available. That tells you how many you're going to share. So you subtract the first two numbers. And then to see how many bonds you should have in that, then it's the S divided by 2. All right, and then you will have exceptions sometimes, as we've talked about before. So I've just come up with a couple of examples, or these 4 examples that should kind of hit all of these different ones we've been talking about. So CO2. All right, so CO2. So I told you carbon's almost always in the center, right? And so we're going to write COO. And I'm going to go ahead and I'm going to say, okay, I know there's at least one bond between the carbon and those 2 oxygens. And then I'm going to write NASB. And I'm going to say, okay, how many do I need? If each one of those atoms had their octet, I would need 8 times 3. So 8, 16, 24. So 8 times 3 equals 24. That's how many I need. How many are available? Okay, well, I look at the group numbers. Carbon has what? It's in group number 4. So, sorry about that. So carbon brings in 4 valence electrons. How many valence electrons does oxygen have? It's in group 6A. So each oxygen has 6. So 6 times 2, because I have 2 of them, which is 12. Okay, so that's, so sorry about that. I hate it when it does this. So 6 times 2 is 12, plus 4 is what? Once I start doing it, I can't stop. So 12 plus 4 is 16, right? 16. Let me see if I can do it without touching it. Okay, so now I've got 24 that I need and 16 valence that I brought with me. I brought 6 from each oxygen, which is 12, and 4 from the one carbon, which is 4. So 12 plus 4 is 16. So to get the number of shared, I'm just going to say 24 minus 16 gives me 8 electrons. So I have to share 8 electrons. So when I share 8 electrons, that means that since there's 2 electrons in every bond, then that means I'm going to have 4 bonds for this. Okay, now I'm going to look at this. I have 1 bond in between each one of these. Okay, so I've only got those 2 places to bond things. So I'm going to say, okay, I got 4 bonds. Can I double bond these? Well, let's see. That's a C and an O, and that's part of CONS, right? So I can have double bonds between those. So the easiest thing for me to do is to do my double bonds. So I'm going to do that. Okay, so I'm going to go back to my available, and I'm going to say I've got 16 available. And when I put those bonds in there, I have that each bond is 2 electrons. So 2, 4, 6, 8 minus 8 gives me 8 electrons. I've got 8 electrons left. So the next step in NASB is to put the electrons around the outer atoms to make sure they have an octet. So my carbon already has one, right? Because it's got 4 bonds, which is 8 electrons. My oxygen has 4 electrons, so it needs 1, 2, 3, 4. And same thing for this one over here, 1, 2, 3, 4. So I just added 8 more, and that leaves me 0. So I'm done. So that is my Lewis structure for CO2. Makes sense? Okay. So the next one is CHCl3. And I'll tell you, in the formulas, usually they're going to write kind of in order what things are supposed to be hooked to what. So, and you can write the H on any side, but so you've got CH, right? And then you've got 3 Cl's. So we said carbon's almost always in the middle, and there's 4 things. So I'm going to guess that it goes like this, Cl, Cl, Cl. All right, and I'm going to go ahead and draw my 1 bond between all of those things. And then I'm going to do my NASB. How many do I need? Okay, I know I need 8. I have 1 hydrogen, okay? All right, so I've got 1, 2, 3 things that need 8 electrons. So 8 times 3 is 24. And then I got 1 hydrogen. So plus 2 gives me 8, 16, let's see, 8, 16, 24 plus 2 is 26, right? And then available, I know my hydrogen has only got 1 valence electron, so I'm going to write it down. And then each one of those chlorines is in 7A, so 7 times 3 of them is 21. So 21 plus 1 is 22. Is that right? 8, 16, 24 plus 2. Oh, wait, you know what? I messed up. I've got 4 things. I forgot my carbon. 8 times 4. 8, 16, 24, 32. That should be 34. Sorry about that. You're probably sitting there thinking that, weren't you? Okay, so I've got 1, 2, 3, 4 things that need 8 electrons, and then still plus the 2 for the hydrogen. Sorry about that. So then I've got valence electrons. I've got 1 plus the 21 plus 4, right? Because carbon also has 4 valence electrons. I was forgetting about it because it was in the middle. So that's 21, 22, 26. My fault. All right, so then this one's easy. 34, maybe I can keep from messing this one up. 34 minus 26 is 8. All right, and so then 8 divided by 2 is going to tell me it's 4 bonds. So I've already got 4 bonds, right? So now all I need to do to make sure that my electrons are right is I go back to my 26, and I say, okay, I've got 1, 2, 3, 4 bonds. So that's 4 times 2 electrons, 4, 8, 12. So that's what? 8 electrons, right? Are you with me? 8 electrons. So 26 minus 4 is 18. No, minus 8 is 18. All right, I'm mathematically challenged. All right, so I've got 18 left. So let's see how many I need on these outer chlorines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yay. So 18 minus 18 is 0. And so that is my structure. See how this is going? All right, and again, if you'll practice this, it starts to really make a lot of sense. Okay, so this next one is PF5. Now, my rule is I'm going to write what I think my central atom is, and I'm guessing, since I got 1p, I'm going to put it in the middle. It's also what? The least electronegative. Okay, so I've got a P and I've got 5 F's, so I'm going to have to write F, 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 F. Well, right away I got more than 4 things attached to this, and so that's telling me what? This is going to be an exception to the rule. So I'm going to say, okay, I know this is going to be an exception. I'm going to do my NASB because even though my bonds may not be right, it won't let me down. All right. So I got NASB. All right. So this time I'm not going to forget that center one this time. So I've got 1, 2, 3, 4, 5, 6. So I need 8 times 6, which is 48. I have available 5 times 7, which is 35, plus, sorry, my phosphorus is group 5A, so that's 5, so that gives me 40. So S is going to be 48 minus 40, which is 8. And so that means that according to that, I should have 4 bonds. Well, I know that that's an exception, right? I know that's an exception because I've already got 5 bonds. But I can still go back and use my available electrons to put these around there and verify, because if I have any left over, they can go on the central atom. So 40, because this is an exception, so it could be really weird. So 40 minus, I've got 5 bonds, so 5 times 2 is 10. That leaves me with 30. And so I've got to finish the octet on all of those F's. So each one's going to get 6, right? Because I've already got a bond there. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay, well that worked because that's 30. 30 is what I have left. And so that gives me 0. Some of these phosphorus ones, like another thing that you might see, you could actually have PF7. You could have PF7. All right, and when you have some of those, sometimes you would end up with 2 extras over here, and then you just have to put them on the central atom just anywhere you wanted to, as long as you put the pairs together. So exceptions are bizarre. Now, are you going to have to do exceptions? The good news is no, you're not. You're just going to have to do the ones like this, which follow the rule. But I just wanted to show you how these work. Okay? Your BCl3, remember me telling you about boron? And I just want to show you this one because a lot of people try to double bond this. Because when you do this, you're going to come up with 4 bonds. You need 8, 16, 24, 32. You have available 7, 14, 21, plus 3 is 24. Okay? So then your shared is 32 minus 24, which is 8. And so it's telling you that your bonds should be 4. Okay? So most people are going to immediately try to double bond right here between the B and the Cl. Guess what? They're not on the list, so you can't double bond them. So what happens is you put your bonds in there. That's 6, right? And if you will do this, like I was telling you, this NASB, you've got 24. You just put 6 bonds on there. Okay, so 3 bonds on there, so that's 6 electrons. So 24 minus 6 is 18. Then you've got 24 minus 6 is 18, right? So then you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So you had 18 electrons, Okay, so you've used all your electrons. And so boron doesn't have 8, it only has 6. But remember, it's one of the exceptions because it's so small. Okay, so I was showing you these exceptions so you can see those, but these are the type that you need to be able to do for your exam. So practice those so that you can get really good at those, okay? Now, if you want to go back and try to do it the other way, that's fine. But remember, you're not going to be able to look these up. So if you do your homework and you look them up on Google, that's all well and good. You'll do really good on your homework. But guess what? When you take the test, you won't be able to do it. So make sure you learn how to do these. If you, I'm going to post another, I'll try to post another video on there too and do some more practice with these, okay? All right.